In this tutorial, we make sure that you understand what integers are, unisize are, isize are, how to be able to implement them in blockchain technologies, and what they are and what they are not, with basic real-world analogies. Okay, that's what we make sure that even if you're a beginner, you're a pro in Web 2, you want to understand Web 3, this course is for you. Okay, try as much as possible to stay tuned throughout this course, and you will understand what an integer is and what it is not. Okay, and as much as possible, do well to code along and relate with the analogies, and go back to this video and take time to go at your own pace. Okay, we are not actually competing with anybody. Go at your own pace and you will get a lot of value from this video. Welcome to BlockForge. My name is Obina Victor, and in this blockchain courses, in this YouTube channel, we make sure that we bridge the gap between developers and resources. Okay, so you want to be the middleman between you as a developer and the resources you need to scale up your portfolio, the resources you need to build amazing projects, to be creative in ideas. And so we are starting from the very basic to the advanced level. So we are taking it from Rust programming language, the core concept. We'll be building projects to solidify what we've learned. Then we now transit into blockchain development proper. If that sounds interesting to you, do well to click the like button and subscribe to this channel. See you guys at the top, and stay tuned, guys. Let's dive into
integer folder that I created with a source file, and these other ones, all this was generated with cargo new and the name of my folder, which is integers. And today what we are going to talk about is data types, and it's quite important you understand data types in Rust programming language, because it will be one of our major arms as we move into blockchain development and build stuffs around it. So I hope that makes sense. So first thing first is to open our source file. You have to open your source file, then navigate to main.rs. You can still rename this main.rs if you wish to. Okay, the name is not actually something that is rigid, so you can change this main.rs actually the way you want. Okay, so first of all, we need to understand what data types are. Okay, and know what specifically data types contain. Okay, in our previous videos, I know very much well that you must have actually come across data types. We have actually done some stuff, written some codes that contain data types, and maybe for some reason you didn't know that this is data types. Okay, or this is what they are. And in today's video, we just do justice to that. First thing first, we have to just wipe out this print ln, this that calls a micro. Okay, now just like data types. Okay, and so okay, we'll just close this tab, Control B to close the left hand side window. So what are data types? Okay, so imagine a warehouse. Okay, so this is what I want you to use to attribute to data type, an analogy for a data type. Imagine a warehouse that you are organizing an items. Maybe you are organizing big items. Okay, this warehouse contains a whole lot of items, and these items, what is giving you an edge to be able to organize them the way they should be is the labels they contain. Okay, so the labeling of those items is now an enhancer that is helping you to be able to organize those items, okay, in the warehouse. So that's the same way the compiler works with Rust. And so the compiler needs to know the data type that you are storing your data with, okay, to be able to know how to compile your code and know where to place your code. Okay, and Rust is statically typed language, which means that at compile time, the variable that you're using and the data you stored in that variable, the data type must be identified by the compiler. So let me give a very swift code. So let's say, let's guess let's guess equal 42. And also sometimes Ross can figure out this data type for us, and in other times we need to explicitly write out these data types. Okay, so just this will be a string, this will be a string data type. So now this here, Ross have already figured this out for us, that is a data type, and we can still figured out the data type for us, that is a string data type, and you can still explicitly add this data type here if you want to. But now it has figured it out for us, and is making our code much more easier to just focus on more better problems than this. Okay, and sometimes this can also be a challenge also. So now, come to think about this squiggly line is because you are not using the guess variable. Now let's just take a case where you want to convert this string into a number. Okay, you want to convert this string into a number, and let's see what happens if Ross can be able to, the compiler can be able to figure out the data type for us. So we just write dot pass. This dot pass is just to convert it to a number, dot expect, and this pass returns an expectation. So this dot pass is taking an action, and so if this action wasn't successful, it will throw an error. Okay, the string could not be converted. The string could not be converted. So now, as you can see here, the Ross cannot really figure out what this is, if what data type it is. Okay, and now this is where we explicitly add the data type that we want to infer. Okay, now first of all, Ross knows that the compiler knows that this is actually a number, but it can't figure out the data type of the number, the integer we want to store. Okay, because we will talk about it in a few minutes about integers, and we have different kind of data types in integers, and now Ross is trying to figure out which kind of integer am I referring to. And so this is where my hands will become dirty. I have to explicitly add the data type. I just say I32, and so this I'm telling Ross that I just want an I32 variable here. Okay, and so if you don't explicitly add this and run your code, you will run into a big error. Okay, a very big error. Let me give, okay, just try it out yourself. Okay, or let me just, since we are in the code already, let me just write this code. Okay, print ln. So this is a number, this is a number, and we want to just store this guess inside of it. I'll just close it. So the squiggly line have gone off. I'll just do cargo run. I'll do cargo run for this to print out. Okay, cargo run will print out this number for us, 42. This is a number. So let's assume that we didn't add this data type, explicitly add this data type, and run cargo run. Okay, now this is the error. This is the error that is showing up. He said we should add the type. There is no type annotation here, so the compiler is requesting that we should add a type to this code that you can't really figure out what data type you want to add here. And so this also helps in Rust safety. This is part of the things that makes Rust a very beautiful language to actually try and explore. Okay, now we have two types of data type in Rust. We have the scalar data types, and we have the primitive compound data types. And the primitive compound data types are of two types, which are tuples and arrays. And also, if you come to scalar data type, you have four primary scalar data types, which include integers, booleans, floating point numbers, and characters. Okay, now we will focus on integers today. Okay, we focus on scalars today, and one of the scalar we focus on is integer. Okay, subsequent videos we now talk about floating points, characters, the compound data types. And why we want to dedicate this video to integers is because if you're working with blockchain, development, as a blockchain developer, most of our codes will be integer related codes. Okay, where we'll be talking about numbers, storing values, storing, formatting a number, hashing a number. You know, it will be much more about, we will write some other codes, other stuff there, but it's much more like a number based system. Okay, don't worry, it's not complex, but that's why I want to dedicate this actual video for integers. Let's talk about integers and what they are and what they are not. Okay, I hope that makes sense, guys. I hope that makes sense. So first of all, what I want to do is this. I'll just indicate here scalars. Scalars, and under the scalars I'll just write integers. Okay, so what are scalars? So think about scalars as bricks that makes up a whole building. They represent a single value. Okay, in Rush programming, they represent a single value. So when you talk about integers, integers are whole numbers. They represent whole numbers. You talk about floating points, floating point value. You are talking about decimal point. We are talking about booleans. You're talking about true or false, and you're talking about character. You're talking about characters. You're talking about alphabet. You're talking about some emojis. You're talking about symbols. Okay, so I hope that makes sense. And so we'll be focusing on integers in today's video, and in the coming videos we talk about these sweet other scalars, the brothers of integers. Okay, so now when we talk about integers, I want you to think about integers as boxes. Okay, boxes of different sizes that contain different stuff altogether. Okay, that's what I want you to think about when you think about integers. Think about them as these are boxes of different sizes, of different shape, that stores only whole numbers. Okay, so whole numbers are numbers like 5 that doesn't have any fraction on it. Okay, that doesn't have any 5.6 or 2 4.1 or stuff like that. Okay, they are whole numbers. So integers are whole numbers that are of different box sizes. And so there are some boxes that are unsigned boxes, and there are some boxes that are signed boxes. And so these signed boxes of different sizes contain only positive whole numbers, while the boxes of signed integers contains both negative and positive whole numbers. So let me show you what I mean. So this is this different sizes of boxes we have in integers. This is U8. We have U8, U16. We have U32. We have U64, and we have U128. I think so. Yeah. And now, and also we have I8, I16, I32, I64, I128. So I'll just comment this out. I will explain what I'm doing here. Okay, let me just take this far away, or let me just wipe out this, since we talk about it later for more clearer view. So you just say that these are signed integers, and these are unsigned integers. And so now looking at these two, okay, so what I explained before was that integers have different box sizes. So this stores only positive whole numbers. Okay, why this stores both positive and negative whole numbers? like this. Okay, now looking at these two, the difference between this and this is that the signed integers and unsigned integer is that the signed integer stores only positive whole numbers, while the unsigned integer store both positive and negative whole numbers. Okay, and the similarities between both is that they store whole numbers. Okay, you cannot store fractions on this. Okay, in integers stores only whole numbers. I hope that makes sense. And now, if you look at this, now there are actually some little key things you have to know down about these integers. Okay, when it comes to integers, sizes matters. Okay, if you're talking about integers, sizes matters. As you mentioned earlier, different boxes of different, so these are different sizes of different boxes. These are different sizes of different boxes. And now this box, this one, I 128 and U 128 are of the same box size, and this are of the same box size. So the difference is just that the values they store in. Okay, that's what makes them unique. Okay, now sizes matters when you're talking about integers storing of values in rows. Okay, sizes matter. Just imagine that you want to, so the illustration I want to give is that you have a jar of water and you have a small cup, and your goal is that you want to make sure that all the water in this jar will contain in this cup. Okay, you are actually messing it up. So you are using something that's a small size container to pour into something that is big. Let me give you another illustration. You're storing a large value in a small box, or you're storing a small value in a large box. So let's assume that you're storing a small value in a large box. In rows is actually a waste of space. So let's say that let age equal age 1 U 128 equal 24 or 24. Yeah, now this might look cool, but actually is a waste of space. Okay, it's really a waste of space. Looking at this here is a waste of space. There is nothing beautiful about this. Actually, you're wasting space. Okay, because you're using a large box to store a small value. So now these values has limits. These boxes have limits of what they can store. Okay, they have different limits of what they can store. Let me go back. They have different limits of what they can store in them. Okay, these values, they have different limits of what they can store in them. And now let's also imagine that you're using, let's say, age, let's say guess guess guessing U8 equals 30 600. So in rows, this is what we call an overflow. Okay, you're storing a large, you're using a large content to store in a small box. Okay, it's called an overflow, and we talk about this in a jiffy. Okay, but let's explain what these things are and what they do. Now the limits of these boxes can be identified. Okay, like this U8, the limit is between 0 to 255, and so anything between 0 to 255 in U that you want to store in U8 is an overflow. Okay, anything outside of 255, let's say 256, is an overflow. We'll still write code on that to explain it more and also explain how to handle it. Okay, now to determine the size of each of these boxes, okay, you don't really need to go ahead and cram it, but you know exactly what this size should be, or what this content what the box should be like. Okay, for instance, if you want to store your age or percentage, you know that is not this you should go for. Okay, is U8 that you should go for. Okay, I hope that makes sense. Now to determine the range of these values is to use this formula 2 raised to the power of the box size itself, which is 8. It can be 16 if you want to determine it, or 32, or 64. So this will give you the maximum limit that each boxes can contain. Okay, we are using box here to actually reference or give us a very good analogy of what these things looks like. Okay, that's what we are trying to do. Okay, so I hope that's clear. So another thing I want us to understand about signed and unsigned integers is that you can also think about them as a bank where you store money. Okay, so you can think about unsigned integer as a pig bank. Okay, piggy bank where they can only hold positive value. Okay, they can only store money for you. They can store your income, your savings. They can store it for you. Okay, so they store those values for you, and they can only store positive. No, they cannot store your um debit for you. Actually, you're the one that owns and earn your debit, and the debit will be to your own personal account number, account details. Okay, bank account. Okay, and so you can think about signed integers as your own personal bank account now, that can hold both positive and negative value, that can hold both withdrawal and deposit, debit alert and credit alert. So these are positive and negative whole numbers that can come in, and so your account can be able to hold both. So you can think about it like that for better clarity and better understanding. Okay, I hope that really makes sense. Okay, and so now having talked about integers and box sizes, and I want to clarify something. Okay, this let's assume that you want to actually store a number. So you want to write some code with signed and unsigned integer. So let's say you want to store a number. I just change this to 8 because you want to store an age. Okay, someone's age, we just save it. And let's say you want to store temperature. So temperature can be negative actually. Age can never be negative. I can be minus 24 years. It can be possible. Okay, so age, temperature can be actually negative. So what I need to do here is to remove this u and add I. Okay, so let me just go back and show us something. So already this is throwing an error. Okay, this is throwing an error, and so if you try to run this now, we will actually bug into a very big error. So let's just run it and know what's happening and see what will really happen and what will not happen. Okay, so this is it. Cannot apply urinary operator. Okay, this minus here, okay, is throwing an error already, and to the type u8, so it's really throwing an error here. So it's saying that this u8 should not be a negative sign. So changing this value, actually what we do is just to use I sign to change this value. So we are changing this value from positive to negative. Okay, it can now hold negative, and the switching run have actually verified. So if you run this again, let's see what the error is we got. So just still giving us this error of that type annotation. The guess we didn't really finish up right in the, let's just go back and finish, because we removed the data type actually we created there. So okay, so this is it. So if you go back and run this again, I should run successfully, and yeah, this is it. So he's saying that guessing if your intentionally prefix with underscore. So he's saying that this I underscore with guessing doesn't really work, but it's fine by me. Actually, I don't really care. So and also the age. And so why these things are not working is because we are not really using them. Okay, so let's try to run this. Let's try to run this code. First of all, you have to use these variables. Just like print ln, um, and just this is my age. I just put in age here and just do print ln. This is the temperature. Just something random. Guessing. So you have called the micro here. Let's just run cargo run and see what will happen. And so this is minus 16 and minus and 24. And now, so if I change this 24 to u8, just do I and see what will happen, if it will throw an error or not. This will not throw an error because the signed integer stores both positive and negative value. Okay, I hope it makes sense. And now, moving forward, so let's try to talk about something very, very crucial that we mentioned earlier. Okay, and also something else to have in mind is that when you're talking about signed integers, we use the letter I and the box size to represent them. And we are talking about unsigned integer, we use the letter or alphabet U with the box size to represent them. I hope that makes sense. I hope it does. And now, when we are talking about overflow, what do we mean? So we mean that you're trying to store a big value in a small container. So you're trying to use a very big booter. You want to transfer the content in a very big booter to a bucket that is very, very small. It will cause a spillover. Okay, that's just what you're trying to do, and it can cause a very big damage. So think about it when maybe you're trying to load let's say 20 bags of rice in maybe, or 30 bags of rice. Let's say for, okay, let's take 50 bags of rice. You're trying to store 50 bags of rice in a very small jeep, or in a Lexus, or in a Rolls Royce. Yeah, let's say you're trying to store 50 bags and you want to convert, you want this Rolls Royce to convert these bags of rice from here maybe to, let's say, 300 kilometers journey. Even if it's 1 kilometer, it's catastrophic. Okay, it's not, they are not equating, the weight and the content are not equating. And so that's what happens in Rust. And so Rust tries to find a way to balance it. And so when those issues come, so when the overflow happens, Rust dictates it and panics and try to end the program. Okay, this is a kind of safety measure so that you not go ahead and damage stuff or cause a catastrophic damage to the system. Okay, that's what Rust does. And also for some reasons, Rust also have actually find a way to help us overcome or control these issues. And one of the way we go about it is to use the wrap method, and the wrap method helps us to reset the value to 0, okay, to the initial starting point. Okay, that's what wrapping helps us to do. Check returns none if the content is bigger than the container. Okay, if the content is bigger than the box, check returns none. And so these are the two methods that we use. And also we have something like saturated, but we'll be talking about these two methods, which are wrapping underscore add, oops, and checked underscore add. That's the two methods we'll be using to go through this control mechanism. Okay, so let's talk about how does this work. So we just do a small code to explain this. Let's say small box equal, okay, let's just put data type u8, okay, equal 255. And so you say that 255 is the limit this can go, is the max this can go. And so we want to modify this. Think what is missing in this code. Remember, we want to modify this variable. What is missing in this code? What is missing here is mute. Mute helps us to actually modify our code. By default, variables are immutable. Okay, we talked about it. Guys. So what we do is just do small. So this writing mute gives us the head to be able to change or modify the value in this variable. Okay, small box +1 +1. Okay, now writing this thing like this will actually throw an error. Okay, because it have exceeded the normal limit of the box we are using. Okay, just checking something. Yeah, just checking something actually. Small box. Okay, so cargo run. He said Threadman panicked at, so there was a panic in this file. Okay, attempt to add an overflow. Okay, there was an overflow here. So what this is trying to do is to try to panic that the system is dictating something wrong, and for some reasons you want to still follow this method. That's why you are trying to introduce the overflow mechanism that will help you control it. But the smartest way to do is just to increase your box size to 16. And so if you run this thing, it won't throw an error actually. There won't be any error thrown. Okay, so looking at this, it has printed that this said checking something at this. Okay, but let's still go through what we're trying to talk about. Okay, now taking this, let's say we still want to go ahead and follow we are doing strong head. So the best thing to do is to actually write this. So you want to control the overflow, you do wrapping plus underscore add. Okay, and what you want to add, the value you want to add on to this is what will be inside of this box, this parenthesis. Okay, and so what we said previously is that this will return back to 0. Okay, it will just reset the whole system back to 0. Okay, this is the control mechanism for wrapping. And so think about it as when your speedometer in your car, when it reaches a certain level, a certain kilometer level, it will reset back. Okay, you can think about it like that. And this is cool, but it's not really much more secure to use it. And so the better secured way is to use this check method, and we'll still write this check method. Let's write some code and introduce this check method and see how it goes. X u8 equal 255, and we'll add this mute here because we want to actually modify the value here. Okay, we want to modify the value here, so we now say match x dot add x dot check add. What you want to add is only one value. If you want to add 2, you can add 2 there, and just have fun. So now remember what we talked about match in our first project, that has patterns. Is just a decision maker that takes a value that was given to it and check which of the options match what he is holding already. Okay, and so this check returns two variants, some and none. And so the S is in capital letter, some values, and we print ln, and also this should be comma, and also none, print ln, overflow dictated. So we're saying an overflow was dictated. Okay, so this is how our code is. Now we are going to, we didn't use this mute because we didn't modify something directly. We are trying to check if this is actually more than this, so that's what we are doing here. So we didn't really modify something. Okay, we didn't use this variable elsewhere, trying to modify it, but here we are trying to modify it. Okay, so I hope that makes sense. So if I run this, it will return this value, okay, that overflow was dictated. So it's just doing like this because of the format I used here. So overflow dictated. Okay, saying overflow dictated. So now this can also be valuable if you're still using a larger box, let's say U16. So this means that if this is saying that if there is an overflow, return none, return overflow dictated. But if there is no overflow, return this. So this we check the x variable, and if there is an overflow, it will hand it over to the match, and match will now use the value that was the overflow and check the first sum and check this sum. If it matches this, it will print this. If it doesn't match, it will go to the next one. If it matches this, it will now print this. Hope it makes sense. And so now we will return the value here because now we are the value here I've checked and there is no overflow. Okay, there is no overflow at all, and so it will return a value for us without running into any check stuff. So it returned 256. Okay, I hope that makes sense, guys. I hope that makes sense. So these are the two common ways you can use to control overflow in Rust. But you can still use saturated, is used also, and the other ones also you can use. But these are the two major ones that I wanted to really talk about. Okay, and so let's talk about something cool. Let's talk about literals, number literals in Rust. Okay, let's talk about number literals, and think about number literals as um different ways numbers can be written. Okay, different formats numbers can be written, and this can come in handy when we are talking about blockchain development, storing values, storing addresses, storing let's say numbers, storing hashes. Okay, this will come in handy, and so that's why I find it very important to talk about number literals. I hope I spelled it correctly. I think I didn't spell it correctly. Okay. number literals number literals. Okay, okay, now so there are a few of them, so we just write it down and try to print it out. Let's decimal equal 98 underscore 222. Okay, let's hex equal oxff equal oxff. Okay, let's octal equal 077. Okay, let's binary equals 0b 111 underscore 000. Okay, let me change it 0v11 underscore 00. Okay, and let's talk about byte. Where you talk about b a. Okay, and so these are the different data types. Okay, these are the different number formats you can actually come across in integers. Let me just close this thing off. So the different data formats you can come across in integers. Okay, and now let's try to print them out. Print so let's try to print them out. Print decimal 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 decimal. I just copy and paste this down. I just write this to hex. This should be octal. And this should be binary. So just add the last one yourself. Just I use it to have fun. You can just play around with the last one. Just add it yourself, and it will still give you the same result. Okay. Octal. It will still throw some errors, but yeah, play around with that. Maybe use that a take-home assignment and run with it. Okay, so this is the different data types. They all printed out, and the last one we also print out. Okay, let me just add it. I just add it here. The name is what? The name is right. And so this will come in handy when you're talking about blockchain, how to store different format to store numbers also. So let's go ahead and talk about sizes. We want to talk about U size and I size. So this okay guys, now we're going to talk about U size and I size. Think about them as expandable boxes that take the size or the shape of the system they are on. So if they are on a 32-bit system, I size and U size will take the shape of 32-bit system. If they are on 62-bit 64-bit system, they will take the size or the shape of the system they are on, which is 64-bit system. Okay, and they are often used for indexing arrays and memory allocation. Okay, because they match the system word size. Okay, that's the reason why they are used for such. So let's write some code to explain this for us to understand what we're talking about here. Let's say let my array, we've not talked about array, but we'll talk about it in subsequent video. Array 10 20 30 40. Okay, and so we say let index equal I size, or let's use U size equal 2. Okay, so what we do is to print this, print ln my my underscore array index. Okay, so the output of this should be, we know what it should be. Okay, and so take note,
arrays are 0 index. Okay, like JavaScript, if you're coming from JavaScript world, you know that JavaScript has 0 index, and so the counting of JavaScript rows, arrays in rows are 0 index. Okay, the counting of rows indexing is from 0, and so this is 0, this is 1, this is 2, this is 3. Okay, now with this we should actually have an idea of what the outcome of this should be. Okay, so what this code is trying to say is that we want to pick the second index in this array. Okay, we want to pick the second index in this array, and so this is where this u size and I size comes in handy. Okay, so assuming there is a negative sign here, we should have used I size. Okay, so let's just run this code and see what you have, which should be 30. Okay, because we are picking the second index here. Okay, which is this. So I hope that makes sense, guys. Okay, guys, in conclusion, okay, choosing the right integer type, use i32 by default. Okay, is safe and efficient. Use u8 for small positive numbers. Okay, and percentage, age, and use I size and U size for indexing collections. We talk about collections in the coming videos. Okay, and also be mindful of integer overflows. Okay, and use raw safe methods, check and wrapping that we talked about. Okay, choose also the right number format. Know the right number format that you want to use to implement a certain data type. Okay, and do well to subscribe and stay tuned for the next video that we'll be talking about scalars, other scalars and raws. Thank you guys. Share this video, like and subscribe. See you guys in my next video. Peace out.